So what you see in front of you is a self-sanitization robot, which I made during the COVID-19 pandemic to help out hospitals. And the main idea of this robot was to like do the sanitization of the corridors of the rooms fully autonomously. And then after the whole sanitization part is done, it should do the sanitize, like it should self-sanitize itself. So what you are seeing is the first prototype, and it was like at that time I did not know too much about ROS and Raspberry Pis, and the resources were also limited because there was a lockdown going on. So this robot was based around the idea of a line follower. So it was basically a very big line follower with a water sprayer on top of it. And that was the main idea, that okay, the robot will spray the corridors with a rotating nozzle, and after spraying the whole corridor and maybe the whole room, it will spray the same sanitization liquid. Maybe it is IPA or maybe it is something else. It will spray the same liquid on top of it by turning its nozzle or by using some other method. So yeah, this is the, like as you can see on the screen, this is the first prototype of the robot, and it works like a line follower only. It can take turns, it can autonomously route. So one problem with this idea was that it's based on a line follower concept. So somebody has to go inside a hospital during the COVID-19 pandemic and lay down the black strips or black tape. But yeah, that is something that was there. Later we realized that okay, we can use ultrasonic sensors to make something called a wall follower. So using that, so we can either use solely that approach or solely use the line follower approach or use a mix of both. And like we did not implement that idea, but yeah, that was one of the solutions. So as you can see, that I am trying to demonstrate, like this is a very old video, but I'm trying to demonstrate what sort of or how sort of what sort of pattern the sprayer leaves, what sort of area the sprayer covers. And in this video you will be able to see that the sprayer is able to spray or is spraying the liquid while the nozzle is varying, and at the end of the clip it will spray the liquid on top of itself. So it was based around a basic Arduino Nano, and it had a few sensors like battery, water level, ultrasonic sensor. Like it was a very basic robot. It did not have that much of a thing. Now you will be able to see the self sanitization. So it is spraying the liquid on top of it so that it can self sanitize. So the idea was that okay, at no point of time apart from turning on the robot, the contact should be made with the robot. So we had again safety features like ultrasonic sensor, so that if a human comes in front, then the robot should automatically stop. If the battery goes low, then it should return to home or return to the starting position. If some miscommunication happens, it goes over the line, or it is not able to something happens basically. If it is not able to work autonomously, then it had a Bluetooth module during using which you could wirelessly communicate or move it back to the position, so you don't again have to touch it or manually move it. Not manually, but you will be moving it manually only, but you don't have to physically touch the robot to move it. So that was the major things we kept in mind. Apart from that, it had a water level sensor, or basically to detect how much sanitization liquid was present, so that it does not spray or does not run the pump dry. And yeah, that is pretty much it. You can enjoy the rest of the video. There is version 2 of this robot also, which I have covered in the video, which we will come to. And the version 2 was basically a fully, like this version 1 is a very janky setup, as you can see. So the version 2 basically tried to cover uh, like improve the design. So it was fully custom chassis which we got made from industrial area Chandigarh. It had the tank enclosed inside, it had the motor, everything closed inside. It looked like a very professional product. It also had UV light under the wheels, so that the floor could be sanitized, because the floor which is under the robot, that may have germs. So just to kill those germs, we also had put the UV light under the robot. That's pretty much it. So second version was almost same as first version, just we had a custom chassis made, and we switched the different we basically switched the concept of like sanitization, of how we spray the liquid. In the second version, we are using the misting nozzles, which are used for agricultural purposes. So why are we doing that is because what we realized is, in the version 1, the problem was that since it was an agricultural sprayer, So it used to wet the floor, the room, wherever the sanitization liquid used to land, it would wet the floor and everything. Like a person could slip if it was a live or an active hospital. So in version 2, we tried to take care of that using misting nozzles. The misting nozzles, as you know, produce a mist, and here you can see me in the video. So the misting nozzles produce a mist, and that mist is very fine. And when it lands on the floor, it stays for quite a small short of period of time. It does not stay there for long. So that was the main idea of shifting to the misting nozzles. And as you can see, this is the newer prototype. So this is a very good looking than the first version. And the main idea was to make it more industrial grade, to be like achieve a more final product using this. It in the second, like in this revision only, we had added a few LEDs also to indicate what is the status of the robot, whether it's in autonomous mode, whether it's in manual Bluetooth mode, or whether any error has occurred. If you see that this version also gets rid of a few of the oscillations or few of the janky, like if you see have seen the first version, then the robot was oscillating or wobbling a lot at the turns. This one does not wobble a lot at the turns because of the design of this robot. For the cell sanitization part, in this robot we had added normal agricultural nozzles. So the idea was that after this whole sanitization process is done, the robot will go into a room where we can use like normal water nozzles for spraying the robot. Because for sanitization or cell sanitization of the robot, it is like we don't need a very fine mist. We need actual because the sanitization is the key thing which we are focusing on. So we need a broader mist or a watery mist, or like full coverage of the, like we want the spraying liquid to be on fully on the robot, so that the sanitization of the robot is complete. So this was the prototype 2 version 1, in which we had used misting nozzles only for cell sanitization, but we did not get enough coverage. That is why we had to shift to the other nozzles. So currently you can see that I had added the LED lights as well as the UV light under the tires, so that like we can take care of more sanitization. And it was based around a simple Arduino Nano and Arduino line follower code. I did not have that much of a coding experience. I had electronics experience, but not that much of a coding or a ROS or a more complex robotics experience. So yeah, that was what I made. And yeah. So now you can see the demo of the new nozzles which we've put in for covering or for spraying cell sanitization purpose. These are very thick nozzles. These are actually made for agriculture purpose, but you can see they have a high coverage of the whole robot. So the whole robot will be self sanitized very good. So the none of the COVID-19 germs would remain on the robot itself. And the like you can touch the robot safely after it has completed sanitization of the environment. Yeah.
I also forgot to mention that a patent was filed for this robot, but it did not. As of shooting this video, it is not approved. It is still a pending patent, but yeah, a patent was also filed for this.
So I would also like to point this out that I would really thank my mother and father to support me during this, like even my brother during this whole journey, because if you see in the video clips, that is my drawing room, or the room in which we house the guests, and the whole room was full of water every day. Like during my testing, water is here, water is there, and my mom did not scold me at all. She was fully supporting me, and yeah, that is how we got through this. COVID-19 was a very tough time for everyone, and I wanted to do this because like you see all of the things that are happening around you, so you want to contribute to it, like you want to contribute something good to it. So that is how the idea of this robot came. This was also like my college also helped regarding this. The CSRC center in my college helped in sponsoring all of the parts that were required for this build, and my college fully supported. That is how this could have been a possibility. Otherwise, like I could not have ever thought of making this robot on my own, because especially because like who will you show after like making, what will you do with it, how will you approach the hospitals? So yeah, that is one thing that I love about my college. So you can see a full sanitization cycle here. It firstly sprayed using the misting nozzles around the like on the floor, and then after the cycle was complete, it stopped at the end of the line, and then it started to